website for this demonstration purposes. Before we get into demo, let me just quickly walk you through with the introduction. So I'm assuming everybody knows some level of Osquery, but if you don't, Osquery was an open source, extensible agent software, or it's even a framework because it can have multiple technologies by means of extensions. It was built at Facebook, and then very recently Linux Foundation has taken it over. The fundamental concept behind Osquery is that the agent sort of abstracts all the properties of the particular endpoint that it's running on in formatted SQL table. And this gives a uniform interface to query endpoint device, no matter what the underlying OS is. And the other part about SQL is the queries are no more just only about the specific property, but because now the entire operating system is converted into an SQL table, the queries can now be relational in nature. So you could actually query, you can get more contextual queries around Osquery. Osquery was built with multiple operating system support, so Mac OS, Linux, and Windows. And the community version or the upstream version of Osquery provides varying level of features on each of these operating systems. It has more muscle on Mac and Linux, but not so on Windows. And that's one of the first things that we built on Osquery, was an extension to provide the real-time events on the Windows via the Osquery agent. And we'll talk more about that. Osquery, the one that's available in the community, is just an agent-only software. So it still lacks a mechanism of deployment and centralized management. And this is where an ecosystem of multiple projects have come up. That's in the line of that same thing is our product. We have some level of customization to take Osquery and convert it into a endpoint security platform. If you ever heard of the word called EDR, we've sort of given it the whole Osquery look and feel of an EDR product. One of the things about Osquery is it's extremely flexible. So you have multiple options of giving Osquery its configuration, or multiple options of how Osquery can log its results. But this flexibility comes at the cost of complexity. Therefore, making Osquery agent run and derive value out of it can be pretty intimidating because it has enormous number of parameters. To know more about Osquery, there's the website and you can read about it. Now, what we have done into Osquery ecosystem so far, I already talked about the extension that we created on Windows. This extension basically provides more muscle into the existing set of Osquery tables by giving the visibility into the real-time activity on the Windows endpoint as they happen. And by real-time activity, I imply that as a process is being created or process is being terminated, a file is being renamed, or a file is being written into, a network connection is being made or disconnection or disconnected, a DNS event and a DNS resolution. There's an entire gamut of these endpoint activities that are being captured by our extension, and all that activity is made available for querying and collection through the Osquery agent. This adds really this turbocharges Osquery with great level of visibility on the endpoint, which is very useful for use cases of determining if there was a breach incident or if there was any kind of analysis needed on the endpoint activity. One of the other things that we have added in our platform is called a client provisioning tool, that is abbreviated with CPT. As I talked about, that deployment of Osquery and configuring Osquery can be enormously complex. The CPT part encapsulates the entire deployment process, and it just makes it a very, very one-line instruction with all the pre-baked configurations and installation part, including the extension. The entire platform is called Polylogyx ESP, which is now being released into the community, and it's available for all kinds of community purposes. This platform gives the unified web interface for managing Osquery across multiple endpoints and multiple devices. It provides some out-of-box configurations so that the burden of configuring and figure out which queries to write and how to configure that is taken away. Of course, it is still the choice of the user And if they want to create some tailor and custom queries, that option is always available. The platform is posted on the GitHub and it is free to use with a very highly permissible license. There is a commercial edition for Polylogyx platform, and for now that is made on a request. For more updates on all the technology additions that we do, you could look at the following links and you can follow us on that. Now, why this ESP is being built? Because it can significantly simplify the following use cases on Osquery and a bunch of other community tools. One of the things that we feel at Polylogyx that a community-driven tool provides an advantage because it gives a collaborative environment, and security being such a diverse subject definitely needs a platform that can enable collaboration, especially in endpoint security, because what we've seen is perimeter level security is no more sufficient. It needs, even if there's an incident that a perimeter level product has generated, that incident needs to be responded to, that alert needs to be enriched, and all for that, the endpoint data is very, very useful. Osquery, because with our extension, it's capturing a lot of data and telemetry about the endpoint, and analytics on that data can help intrusion detection. And we also have some traditional AV style features for the analytics. The platform can be used to do compliance checks for vulnerability management, or if all the software in the organization are at the level where they're supposed to be. The platform can be used for aggregating logs from multiple endpoints. So log monitoring is a very interesting idea. We've also given the entire platform a SDK interface, and that allows for integration into various other products like a SOAR product or like some kind of an automation product. And in the demo, we'll talk about that. We also have a streaming capability in the platform that can pump all the collected data into some other big data analytics system, which could be built on Elastic, or it could be Splunk, or it could be a more traditional SIM. And that allows the analyst or the end user to perform all level of endpoint activities from a single pane of glass, and they could do correlation across multiple alerts and data coming from different sensors. With that, I would like to start the demo part. And if there are any questions, maybe we'll just give a couple of a pause here for so far before we get into demo. All right, let's move on to the demo stage. So I'm just going to stop sharing here because we're going to now move on to our other screens, which contain the demo related pieces. So like I mentioned, the entire platform is available on GitHub. This is the GitHub link that you can see on the top. It is also posted on all our social media outlets. And here we'll just walk you through. The instructions are also written below the page, but we'll just walk you through the whole process on how the platform can be provisioned. For Osquery, I had already provided the link, but the same link, as you can see, is up here. This is if you want to learn more about Osquery and the things it does. And the extension that we have created, which adds all kinds of real-time telemetry into the Osquery agent, is also available on GitHub. And there's a lot of documentation around that that tells you about the various tables that are being created by our extension and the level of telemetry it enhances into the base Osquery agent. So now let's begin the provisioning aspect of the platform. The platform is on GitHub. It can be deployed on any machine with the Docker client. The platform is shipped as a Docker that gives us a cross-platform deployment option. The only criteria being that the server on which the platform is being provisioned should have internet connection, and the ports 5000 and 9000 needs to be available. So with that, let's start the deployment process. The first step, as mentioned in the documentation, is about cloning the entire platform. This will bring all the code and other binary pieces from the GitHub onto the local piece, which is pretty obvious. Now, once the platform is cloned, the first thing that we need to add is the environment file. The environment file is the various sort of preloaded variables that are needed for the platform to provision itself. They're pretty self-explanatory, but it's like user password for the web console, And then there are a bunch of threat intel API keys, which we can talk about a little later. Now, the communication between the agent and the server happens on encrypted channels through a secret. So the enroll secret is any user-defined string. We've just given it secret. And then the other pieces, you can just leave them as it is, because these are what the Docker is going to pull out to for all its dependencies. Now, I talked about that these communication between agent and server happens on SSL that requires certain certificates to be provisioned. And we have a provisioning script for that, which just simplifies the whole job. The only thing required is that you provision with the exact IP address or the domain name that is tied to the server, so that the agent and client can understand each other. With this script takes some very simpler parameters, which is the IP address essentially of the server where it is running on, or the domain name of the machine that you need to provision the certificate with. Once the certificates are provisioned, they are copied into the appropriate directory wherever it's needed. And at this point, the only thing that is needed is a simple Docker compose to start the container where the ESP platform is available. And these all instructions are also available in the same sequence on the GitHub page. Now the client is provisioning itself, and it's going to pull out all the dependencies, and it'll start all the dependent containers. And once it is done, you could actually log on to the, using the web browser, you can log on to the web interface of the server by the following command. And we already have the pre-provisioned server to skip the part, because while the Docker build up can take some time. You provide the admin, the user and password that was given in the environment file. Easy peasy so far, and that takes you inside the server. The server welcomes you with a dashboard of all the endpoints. In our test server, we already have one endpoint of each operating system already available. But we'll still walk you through how an agent is provisioned. On the top right corner is the CPT tool that I mentioned about, and it's available for all the 3 flavors of the operating system. And deploying the agent just requires running this simplified command. This takes away the entire burden of Osquery config and Osquery flag file and all that complexity around that. So let's provision a Windows machine using this command and the tool. Now, this is the same command that we saw on the documentation part. We download the executable and the certificate. These are the 2 things needed. For a mass deployment, this command can be executed via a centralized management server like SCCM or Chef or Puppet. Once the command is executed, this thin installer is going to pull out all the necessary dependencies from the server. And it's starting its deployment. Nothing else is needed. Everything is auto provisioned and auto configured behind the scene. And once the installation is complete, we could see the server, the agent provisioned into the list of hosts in the host page. So here you can see the 3 provisioned servers that we have, and the one that is getting provisioned will show up soon here as and when it is done. And that's the new one that everybody can see. This is the new agent that we have provisioned. So at this point, we have a centralized server. We have agent deployed on different types of endpoints. And from one single unified interface, we can now query the properties of these different operating system. And this is the simplicity and the beauty of the Osquery architecture. So for example, let's say we want to query from a central place, what is the system info of each of these operating systems or each of these agents. There's a very nice query builder here that allows you to do live investigation. As I mentioned, everything about Osquery is presenting it as tables, and those tables can be queried with the SQL syntax. Sending this query is going to return us data about the system information for all these different operating systems, all within one same command. And there you can see that it is all showing up the system information about each of these different agents that are being managed through this server. And we have data from all the 4 machines. Now, in Osquery world, live query is one aspect that gives you data about the endpoint through a live investigation. But Osquery can also be configured with certain queries. That's the whole Osquery configuration aspect, with pre-populated tables or pre-populated query strings and intervals. So in our platform, we have some out-of-box configuration, which we feel are pretty interesting for most use cases. And then we've given an interval to them. Some of them are derived from a lot of community knowledge and a lot of exchanges around that, some of them through our own experience. This all can be configured. You can add or remove any of these queries and create your own. Besides this configuration, as I mentioned, that our extension on Windows is about capturing the real-time telemetry that's happening on the client side. And this can be overwhelming because Windows is a very chatty operating system. So to suppress the noise and suppress all the white noise, what we have done is we have created certain filters for all these white noise elements. And if any of you is familiar with the tool called Sysmon, you would see that Sysmon is a very extensive set of filters. A similar syntax is here. Once again, the stress here is on collaborativeness, that whatever the community is leveraging in Sysmon or other such tools can also be built here. So you don't have to really reinvent the wheel. So these are the various filters that we have taken, which are, pretty stable about that can be safe enough to ignore the noises from these parameters. There are similar configurations available for Mac and Linux, and of course you can change them, you can add them on your own. The whole idea of these intervals is at these specific times or at these specific cycles is when the agent is going to push data from the agent side onto the server, and the server is collecting all that data. So now we can have a look at the data that these queries are resulting on the hosts. So if we look into a Windows host, all these queries have resulted into data that is collected on the server. So you don't really have to go physically on the endpoint to see. These are the various tables that are available in the community version of Osquery. And then as I talked about, that there are various tables that our extension provides. So for example, the DNS lookup and the DNS response. These are very rich telemetry that is coming out of the endpoint that our extension generates, and it is made available through the Osquery infrastructure. One of the other that we recently added is about visibility into the SSL events. This captures the SSL telemetry of every SSL connection. And as I'm sure everybody's aware that modern malwares are actually moving away from HTTP to HTTPS protocol with the availability of free certificates like from Let's Encrypt or other such agencies. And this essentially simplifies monitoring the SSL traffic that's happening through the endpoint population. What we also have here is the ability to create rules. Now this data, to make this data more meaningful, it's very interesting to create rules on it based on which certain alerts can be triggered. Now, the data from the agent is landing on the server in formatted tables because it's all SQL, right? That makes us creating rules a very simplified process. The only thing prerequisite about creating a rule is one needs to know what columns to apply the rules on. And that information, we have to revert to the documentation for Osquery schema, various tables that are in Osquery. And if you want to apply the rule for a table that is coming out of an extension, for example, in this case, Polylogyx extension, then each extension writer also provides their table schema, and then using that column, the rules can be created. The rules can be as simple as process name being word.exe or process name being explorer.exe or things of that nature. And then there is a logical interface to combine conditions of different types and then create a composite rule. The rules can be disabled or enabled. Some of these rules, this rule interface is very useful if you follow frameworks like MITRE, which continues to publish the different TTPs, and those behavior TTPs can then be translated into the machine format using those rules. Once these rules hit, we get an alert, and there is an interface for alert. But rules is not the only way to get alerts. We also have connectors to some public threat intel repositories. And if you if you have a subscription of any of these repositories, the platform could be provisioned with the API keys. Most of them have a public API or a free service with limited features as well. So the platform can work even with that. But of course, the lookup frequency is going to be somewhat limited with the public keys. The whole idea of these keys is that the indicators that are getting collected on the platform are being regularly matched and looked up on the using these using these threat intelligence directories to give you a visibility in case there is a malicious file being found on any of the endpoint, but probably missed by the antiviruses. This is the second way of generating alert. And the third way of generating alert is, let's say you subscribe to some proprietary indicator list from a vendor or an MSSP. They are not yet part of the public directory of these threat intelligence databases, or they may be very, very specific to the organization for some other reasons. Then the IOC section can be preloaded with those IP addresses or domain names or file hashes, so that the moment the agent returns the data, and any of those columns contain the values that are that match with the one provided here, it'll generate an alert. So user-defined list, the public directories of threat intelligences, and rules. These are the three ways of generating alerts on the platform. As soon as there's an alert, the alert can be navigated through the alert screen, which will show up all the alerts. And taking a little time. Yeah, so this is where the alerts table will be visible. The platform can also be configured to email these alerts. So under the management section, there is an option to create an email. So you don't really have to look onto the platform every time to know whether there's an alert. The alert gets emailed to the analyst or to the SecOps in charge, or anybody who's tasked with endpoint security management. And then on receiving the alert, the individual could log into the server. One of the other things I talked about is that the platform can be just configured as a very simple, lightweight middleware to aggregate data from the different endpoints. And then that data can be forwarded to a third-party server like Elastic or any other big data system. This is achieved through rsyslog. The platform has a container which contains the rsyslog daemon, and that can be configured through a very simple rsyslog syntax, which just requires the IP address of where the data needs to be forwarded. The current server that we are demoing it on is configured to forward all the data to a Greylog. A Greylog is again an open source product that allows different type of log aggregation and management. But it could be a Splunk, it could be Logarithm, it could be any SIM or any or a bare metal elastic system. The advantage of doing this thing is that these other platforms are much robust and much more flexible in terms of their visualization capabilities, their analytical capabilities, and their reporting capabilities. And this allows you to collect data from multiple sites and then do interesting analysis on that data. The other thing on the platform now is I've talked about that we have some AV-like features, and that comes through the Yara engine. If there is a repository of Yara rules that is a part of your subscription, those Yara rules can be uploaded, and these Yara rules are pushed onto the endpoint. Yara rule feature currently is available only on the Windows endpoints, and those, the moment there is a Yara signature that matches a given file, the alert is generated onto the server. For easy management of endpoints, there is a facility for tagging. Tagging is just a user-defined string that gives you ability to group endpoints of similar posture together. And the idea behind that is that group endpoints with the same tag can receive the same configuration, can receive the same policies. So maybe high security endpoints, low security endpoints, and the number of queries or kind of queries to run on the entire group is achieved by the purpose of tagging. There is a feature for carves. Carves is a way in the platform to acquire file from the endpoint, and why that is needed is sometimes when there's an alert and the alert is somewhat in the gray area, which basically says that it may or may not be entirely clear whether the event was a suspicious or a malicious activity. Carves allows to acquire that particular file from the endpoint, and then it could be thrown into a sandbox, or it could be sent for further analysis or forensics to come to a conclusion whether the particular activity represented a malicious event. Now, as the data is getting collected on a DB into the server, one of the ways of looking at data we already saw by going through the host and navigating onto individual endpoint, but this can make searching across this data, the aggregated data, a little difficult, especially if you have to search a given list of all the blacklisted indicators. And that feature is simplified by going through the hunt interface. Hunt interface takes the input file, a line separated file, which is just a list of blacklisted indicators. And then it would be matched across the data that is being collected through various endpoints to know if any of the endpoints have exhibited that blacklisted container. So this is sort of a summary of the entire platform. I talked about the various use cases in which this platform can be used. It can be a significant replacement for a commercial EDR, depending on the threat intel keys and the other pieces. The next thing that I want to talk about is that whole platform actually is available with programmatic interface through our REST APIs. And that entire REST API today is being packaged as a Python SDK, which is also available on GitHub. This is where we really hope that community can also collaborate in making interesting playbooks on these scripts. We have given certain sample scripts. This also implies that you need not really log on to the user interface of the server and go through each of the operations by clicking various menus, because these APIs allows for automation from a remote system. And then this is the whole, many extensions to the platform can be created by this SDK aspect. So just to show you how we do, we're just gonna run some of these very simplified scripts. There is a SDK in Python, but it need not be in Python because it's just a wrapper on the REST API. This particular script that we ran, this script is the same, similar to the one that we sent through the live query interface, which was getting all the system information. But here it is all done through a REST interface. So imagine that you wanted to write a program where you figure out whether each of my endpoint is beyond a certain version of operating system or beyond a certain version of hardware for your compliance checks. So all that can be done through an automated manner using this REST API. Some of the more interesting use cases on these REST APIs could be, because we capture all kinds of file events and file activity. Let's say we want to figure out what are the files that were in the downloads folder into the user system. And this is all wrapped into a file table. This gives us all the files that are available in a user's download, in the endpoint's downloads folder. And why this is useful, or this playbook can be useful, is malwares typically download some stage of their malware into the downloads directory by default using the browser interface. And here you can see that not only we figured out what are the various files available in the download folder, we also have the hashes of them, which is interesting because now the script can actually be extended to look up the reputation of these hashes. So using one script, now we can compute the hashes of all the files available in the download folder, and at the same time also look up the virus total reputation of these things. Here is the API key, which is a public key, so it might take a little time because the public key is restrictive in the number of queries that can be looked up per minute. But the whole idea is, if somebody had a more professional key, now through a very simple script, threat hunting across a population of endpoints, a heterogeneous population of heterogeneous endpoints could be simplified using this whole platform. So now the virus total reputation is being fetched. In this script, we are only looking at the file indicator, but as I talked about the agent side, that we capture a very, very wide variety of indicators, including IP addresses, domain names, HTTP URLs, the SSL certificates, and each of these indicators could be used for analysis through either a threat intelligence feed or through some kind of a big data logic like anomaly detection or outlier detection, and all that interesting aspects could be built on it. Similarly, this could also be used for cross-product correlation. So taking up alerts from a SIM, which are being generated probably through a perimeter device like a firewall or an IPS, and extracting out bits like MD5 or other file hashes, and then scanning the endpoint using this script. So that is the whole SOAR integration. And we did one such integration with Phantom product. Here we've seen that in the endpoint that we were actually monitoring, we do see a malicious file, which is actually really not a malicious file. It's a tool, but that tool is often being used by a lot of malwares. The tool is called Process Hacker, so many of the AVs consider it as bad. But the point being that this is how threat hunting or intrusion detection can also be served on this platform. We did the first of this series yesterday, and we saw pretty healthy downloads and clones of the repositories. So I'm sure people are finding it very useful. I hope the trend continues. I am particularly quite excited about the idea that hopefully other people also contribute into the SDK aspects, so we can have shareable scripts or shareable playbooks across multiple organizations for endpoint threat hunting or other such best practices. So really, really thank you very much. Any feedback on this, the email ID is available on the GitHub page. Any feedback or any suggestions, more than happy to do it. Already talked about that we also have a commercial version of the platform, which essentially comes with support and some additional features. If there's any interest, please drop us a mail and we'll get back to you on that as well. Thank you.